Hey guys, let's take a look at section 4.4, which is on solving equations that are either exponential or have logs in the equations. And there's a few techniques we're going to learn in this section, so make sure you take good notes, even if you just write it in your notebook paper. These are all in the guided notes in Canvas, but make sure you write down these examples. And you'll also want your calculator with you. I'm going to talk to you a little bit about what buttons to push in your calculator when you're solving some of these equations. So let's go ahead and get started. Example 1, it says solve each exponential equation for x by rewriting each side as a power of the same base. So let's clarify what's happening here. First of all, make sure you see that this is an exponential equation because you have 2 to the x power, so that's like your exponential function, 2 to the x equals 32. So one way to solve these is if you observe that both sides can be written as a power of the same base. And 32 is actually a power of 2. Take a minute and use your calculator if you need to and think about how many times or what number would you need to raise 2 up to get 32. In other words, 2 squared would be 4, 2 cubed would be 8, 2 to the 4th power would be 16, and 2 to the 5th would actually be 32. So what I'm going to do is I'm going to rewrite the 32 as 2 to the 5th power. And again, I'm doing that only because I had a 2 on the other side. So I could rewrite both sides as a power of 2. And then take a look what you've got. It's really like a one-to-one correspondence. If I have 2 to the x equals 2 to the 5th, then what does that indicate about the exponents? Since the bases are the same, the exponents have to be the same as well for this to be a true equation. So I'm going to drop the bases and just set x equal to 5. And that's going to be our solution, x equals 5. Take a look at the next question. We've got 9 to the x plus 1 equals 81. And so think about, could I rewrite both sides as a power of the same number? And you may notice that 81 is a power of 9. 81 is 9 to the 2nd power. So I'm going to rewrite the 81 as 9 to the 2nd power. And then the left side, it's already got 9 as the base, so I'm just going to rewrite it 9 to the x plus 1 power. So then we have 9 to the x plus 1 equals 9 to the 2nd. And since they both have a base of 9, what has to be true about the exponents? They have to be equal. So I'm going to drop the bases, and I'm going to set x plus 1 equal to 2. And I'm going to solve that from there. So we're going to subtract 1 from both sides, and we get a solution of x equals 1. Okay, I'm going to add another example that's not on your paper that's a little bit more involved because I want you to see this in case there's any in the homework like this. Let's take a look at the number. Let's do 4 to the x minus 3 power. And I'm going to set that equal to, let's do 16. No, let's think of a better number. Let's do 32 again. Okay, so I have 4 to the x minus 3 power equals 32. Now, I can't write 32 as a power of 4. In other words, 4 raised to a power, there's nothing I can raise 4 to that will get me to 32. However, I can rewrite both of these sides as a power of some other number. So remember 32 from our first example. 32 could have been written as 2 to the 5th power, and I chose to use 2 to the 5th power. Well, I used to because there was a 2 on the other side of that equation. In this example, if I can rewrite 32 as 2 to the 5th power, how can I rewrite 4 as a power of 2? So 4 would be 2 to the 2nd power. So I'm going to rewrite 4 as 2 to the 2nd power, and then there's still the x minus 3 there, so I'm going to put that in parentheses. So look at where we're at. We've got 2 raised to the 2 times x minus 3 power equals 2 to the 5th power. So I've written both sides as a power of the number 2. So now they're both a power, they both have the base of 2, so I can go ahead and drop the bases and just set the exponents equal to each other and solve the equation from there. We can distribute the 2, so we get 2x minus 6 equals 5. Add 6 to the other side, we get 2x equals 11. Divide by 2, and we get x equals 11 halves. and that would be our solution. So it may be a situation with some of these where you can write both sides, or you need to write both sides as a power of the same base before you can set the exponents equal to each other. Okay, so that's one technique for solving exponential equations. Another technique is converting from exponential to logarithmic form. So we've talked a lot in this chapter about how to convert between the two forms, log and exponential functions, and converting between the two forms. Before we jump in and do this example, let's review that really quickly about how to convert between the two forms. So I'm just going to kind of write this off to the side here. So let's suppose we have 4 to the x power equals 17. So we have an exponential equation here, and if I said convert this to logarithmic form, remember how to do that. We said if we had y equals log base b of x, to convert that to exponential form, we would say b to the y equals x, and vice versa. Remember this definition of logarithms. This is how we converted between the two forms. So let's use that here. So I've got 4 to the x equals 17. If I wanted to convert this to logarithmic form, what would this look like? We would write log base b, remember I always write the base first, so log base 4 of the other side, 17, equals x. So remember that, the swoosh thing where we kind of draw the arrows. So log base 4 of 17 equals x, and then we would solve the equation from there, okay? So remember this definition for converting between log and exponential forms, because we're going to use that quite a bit in the rest of this section. So when we have an exponential equation where we can't use the technique of rewriting both sides as a power of the same base, we're going to use that definition of logarithm. So we're going to convert this expression, we're going to convert this equation into logarithmic form. So I always start with the word log. Log of base what? So the base here is e of the other side, which is 7, equals what you're taking, or what the exponent is. So log base e of 7 equals x. Now normally we don't write this as log base e. Remember what kind of a logarithm we have when the base is e. That becomes the natural log of 7 equals x. Now this is a valid answer. This is called an exact answer. So you may see some questions in my math lab where they ask you to leave it in this format. X would be the natural log of 7, would be a valid answer. But you may also ask to write this as a decimal. And so let's just make sure we know how to do that in our calculator. So I'm going to go ahead and remind you about the natural log key. So your calculator may be a little different. That's why I said make sure you have your calculator out so you can push these buttons with me. But the natural log key, remember, let me zoom out a little bit. The natural log key is on the left side of my calculator. So there's my natural log key. So if I wanted to evaluate the natural log of 7, and I want to get a decimal for that, I'm just going to punch in the natural log key of 7. Close the parentheses there. Let me zoom in a little bit. So we've got natural log of 7, and then hit enter, and it gives you a decimal. So pay very close attention in my math lab to how they tell you to write the answers. If they say to write it as a decimal and round it to 2 decimal places, make sure you round it correctly, otherwise they might mark it wrong. So if we were to put a decimal answer down for this, then we would say x is approximately equal to 1.95, and that would be our answer. Okay, let's try the next one. So do you notice there's an extra thing happening in this equation that we haven't dealt with so far? We've got a coefficient of 3. Remember, you can't multiply 3 times 2 because of the exponent. So I have to get that 3 out of my way. So the way I'm going to do that is I'm going to divide both sides by 3. And so if you have a calculator, well, you've got your calculator there, hopefully you can go ahead and make that a decimal if you want to, just to make the numbers a little easier to work with, so we don't have to deal with that fraction. So 42 divided by 3. Oh, that's 14. That wasn't a decimal. So we have 2 to the x equals 14. And then from here, same idea. I can't write 14 as a power of 2. So my only option is to convert this to logarithmic form. So it's going to be log base 2 of the other side, so of 14, equals x. And what that does is it gets the x by itself. Now, the book may ask you, or in my math lab, they may ask you to write this using natural logarithms or common log. So as a natural log, remember the change of base formula. So the change of base formula we had in the last section, remember the change of base formula, we write it over here again. Log base b of n is equal to, you could write it as the natural log of n divided by the natural log of b. You could also write it as the common log of n divided by the common log of b. And so if I were to apply that here, make sure you see what's going on. The base goes on the bottom, so we'll have the natural log of 14 divided by the natural log of 2. That's what our x is equal to. So in my math lab, they may ask you to leave your answer as natural logs. If they ask you for a decimal, then you're going to go to your calculator again. And so in my calculator, I would just punch in the natural log of 14 divided by the natural log of 2, and I'd get a decimal answer that way. So x would end up being approximately 3.81, it looks like. And there we go. Okay. Okay, let's take a look at the next example. We've got 4e to the 2x minus 3 equals 2. So we want to isolate the exponential term. The best way to do that, think about just solving this like a normal equation. I want to get this e to the 2x by itself. So what do I need to move first? I'm going to add 3 to the other side. And so that gives me 4e to the 2x equals 5. And then I need to get the 4 out of the way. So I'm going to divide both sides by 4. Cross those out. So we have e to the 2x equals 5/4, and if you want to make that a decimal, just so you don't have to deal with the fraction, you certainly can. All right, so then think about what would we do from here. Obviously I can't write 5/4 as a power of e, so I'm going to have to switch this to logarithmic form. So that's going to be, let's see, that's 1.25. So I'm going to switch this to logarithmic form. So it's going to be log base e of the other side, so of 1.25, equals the exponent of 2x. Okay? Remember, we don't normally say log base e. Instead, we say natural log. So we're going to say natural log of 1.25 equals 2x. And then I still need to get the x by itself. So to get the x by itself, what do I need to do with that? 2. I'm going to divide it on both sides. And then I'm going to go to my calculator. My pen is dying here. Let's go to the calculator. We could leave the answer like this, natural log of 1.25 divided by 2. That would be an exact answer, but let's get a decimal for it just so we can practice it. So we've got the natural log. It's a little darker here. We've got the natural log of 1.25. And then we're going to divide, make sure you close the parentheses off there, otherwise it's going to put the 2 inside the natural log. So we want to get the natural log of that numerator divided by 2, and we get 0.11, it looks like, approximately 0.11. Make sure you're practicing using your calculator, so when it comes test time, you've got the calculator and you've used it, and you know how to get the right numbers. So we're going to have x is approximately 0.11. Okay. Okay, let's take a look at the last one on this first page. So we've got 2 times 3 to the 2t minus 5 minus 4 equals 11. So same idea as the last question. I've got to isolate the exponential, the 3 raised to the 2t minus 5. I've got to get that by itself. So the way I'm going to do that is I'm going to add 4 to the other side. Cross those out. So we get 2 times 3 to the 2t minus 5 equals 15. And then we need to divide both sides by 2 to get the 2 out of the way. And if you want to make that a decimal, just so you don't have to deal with the fraction, I believe that's 7.5. Okay, so if we divide both sides by 2, we had 15 over 2, and that's 7.5. So I've got 3 to the 2t minus 5, and the exponent equals 7.5. All right, so think about what we've been doing in the last couple of examples. I can't rewrite 7.5 as a power of the base of 3. So my only option is to switch this or convert this to logarithmic form. So we're going to have log base 3 of the other side of 7.5 equals what's in the exponent, 2t minus 5. Now, I will probably want to go ahead and get a decimal for the log, that left side, using the change of base formula. so that we can put it all together with the t, or with the numbers on the other side, and get the t by itself. So I'm going to have, if you use natural logs, I'm going to have natural log of 7.5 divided by natural log of 3 equals 2t minus 5. Make sure you see what I did. This is just an application of the change of base formula. And so let's get a decimal for that from our calculator. So let me go to the calculator here. And I'm going to put in natural log of 7.5, close the parentheses, divided by the natural log of 3, close the parentheses, and I get a decimal on that left side of 1.83, I'm just going to say 834, equals 2t minus 5. And then we're going to solve it from there like a regular equation. So what do I need to do with the 5? Let's add 5 to the other side. So I get 6.834 equals 2t. And then we're going to divide both sides by 2. Let's put that in the calculator. 6.834 divided by 2. And I'm getting a value of about 3.42 if we round it off. 3.42. Check it with your calculator. Make sure you're getting the same answer that I am. Okay.